Unit 8, Chapter 8, combining two sections together. First one on describing polygons, and the second one in finding the measures of the interior and exterior angles of polygons. So, first off, we have two different kinds or types of polygons. They can be classified as convex, and if you look at the picture here, just means if you would extend the sides, they would never pass through the interior. And the second type is called concave. Think of the word, partial word in there is cave, so it caves in. Okay, so if we go with that same philosophy of drawing the lines, extending the sides, when you extend one of the sides, it actually goes to the interior of the polygon. So we're going to identify whether the polygon is convex or concave. And looking at the first one here, if I would extend this side, it goes through the interior, crosses through. So this would be concave, or it caves in. In the second one, you extend the side, any of the sides, and it doesn't go through the center at all. So this would be convex. When we classify, we can also classify polygons as equilateral, equiangular, or regular. Equiangular, as it says, is equal angles. EQUI is equal, angular angles, equal angles. Same with equilateral. Lateral means side, EQI, equal, equal sides. Regular polygons are convex polygons that are both equal angular and equilateral. So sides and angles are congruent. Okay, so we're going to classify as, or determine if these are regular. So when I look at this first one, I take notice that there's double lines there and singles here. So this is not equilateral, so it's not regular, but it is equiangular. Second one, see, we have equal angles and we have equal sides. So this one is regular. And in C, the first thing I notice is that it's concave, cannot be regular. And the reason being is, if you take notice, there is no way this angle here could be equal to any of the other ones. Continuing forward, though, we do see that all of the sides are congruent, so this would be equilateral. So determine if these polygons, first decide if it's convex or concave, and then is it regular. If it's not regular, just say what it is. We're going to write down what it is. So the first one is convex, doesn't cave in, and it's equilateral. The angles are not congruent, but the sides are. Number 2 is concave. It does cave in, and it's equilateral. And the last one is convex. Notice equal angles, equal sides. So this is regular. And that's really all there is for the first section. So what does it mean for a polygon to be called regular? It's equilateral and equal angular. And can a concave polygon be regular? And we already mentioned that. Cannot be regular because it can't be equiangular. Okay, so then moving forward, we're going to talk about the angles in a polygon. So first off, if you look at these two polygons, red inside angles are the interior angles, and they're highlighted in red in both of these. If we extend the sides only one direction, okay, one extension per angle, interior angle, that outside angle created in blue is called an exterior angle. To find what the sum of all the interior angles would be of any polygon, you take the number of sides, subtract 2, and take it times 180. And the reason that is if you would go from one vertex and draw the number of triangles, we'd have 1, 2, 3, 4 triangles, or n minus 2. 6 minus 2 is 4. And a triangle, the interior angle is equal, sum equals 180. So it would be 4 times 180. So that's how that is derived. So the steps for finding the sum of the interior angles is first to figure out the number of sides. Find your n. So it's either the number of sides or the number of angles. Then use our formula. So it would be 7 minus 2 times 180, which is 5 times 180. All of them would add up to 900. Then we can use this information to find the missing angle in a polygon. So the step process for this one would be n equals 6. Find out what all of them equal. So 6 minus 2 times 180 is 720. Add up what you have. If I add up 88, 142, 105, 136, and 136, I get 607. My measure of angle A I'm going to call x, and all of them must equal 720. So you subtract 607 from 720. So the measure of angle A would have to equal 113. And we'll get some more practice with that. To find the measure of just one interior angle of a regular polygon. So think first, you know that all of them must be the same. So I need to find out how many I have first. It's an octagon, so it should have 8 sides. So n equals 8. So I find all of them. All of them equal 6 times 180. But an internal is just 1. So if all of them equal 1080 and I just want to know 1, I have 8 of them all together. And you divide that out. So 1 would equal 135. So let's put this in practice. There's 3 of them here to try. So finding the sum of all of them is the first step. So n equals 5. So you do 5 minus 2 times 180. Add up what you have. So your unknown plus 468. And then subtract. Find your n. Find out how much all of them add up to. Add up what you have, call the unknown an x, and then subtract. Find your n. Find out how much all of them add up to. Add up what you have. Don't forget the 90-degree angle. Must equal what all of them equal. Subtract. And to find 1, twelve sides is going to be 12 minus 2 times 180. Okay? And then, which is 1800, I'm going to divide by how many I would have. I would have 12. Interior angles. And then this last section is the exterior angles. Remember, if you just draw an extension of one part, you have an exterior angle. And it doesn't matter how many sides you have in your polygon, all of the exterior angles will add up to 360, no matter what. They will create a circle. Okay, so if you cut them apart, piece them together, they will create a circle. So all you do is add up what you have. So I have 3x plus 95 plus 85, which is 180. And no matter what, exteriors always add up to 360. So x would equal 60. So some exterior angle practice. Again, just add them up. So you get x plus all of those numbers there. Don't forget the 90. Solve for x. Add up what you have. Always equal to 360. They're exteriors. Solve for x. Add up what you have. Exteriors equal 360. Solve for x. Add up what you have. Exteriors equal 360. Solve for x. So then to close this lesson, what do you know about the measures of the interior angles of a convex polygon? Okay, the sum of the measures of the interior angles equals n minus 2 times 180. And this ends the double lesson, 8.1, 8.2, classifying polygons and interior exterior angles.